Okay, let's get started. So what I have in front of you is the final exam schedule. So this is Strategic Management of Information Technology, and our exam is broken out into two groups, and it will be on Wednesday the 27th. And that means we don't have any class on Wednesday the 20th. So we have 2 weeks left. We have actually 2 weeks after this week, I believe. Let me take a look real quick at the calendar. I can find my calendar. Let's see. Make this a little bigger. So today's the 30th, and then we have, oops, wrong direction. We have next week, which is the 6th, and then we have the 13th, and then we have the 20th. So we only have 2 classes left, the 6th and the 13th, correct. So we do have 2 classes left. On the 13th, because the 20th starts, we have the week off. On the 13th, I'm going to have a final exam review. So that'll be the most important class. If you miss it, you can always catch the video recording of it. And what I'm going to do is go over everything that's on the final exam. I haven't written it yet. For this particular class, we only have 70 students, and I'm only going to have one version of the exam. And the other classes I've been doing multiple choice with, and it works great when there's a lot of people in the class, and it's easy. But I think it's harder for you guys. I'd rather have you guys do a written one where you can answer in multiple different ways, where you have multiple correct answers versus one correct answer. And I think the short answer is a little easier in terms of the format for you guys. Correct me if I'm wrong. Would you rather have a multiple choice?
Multiple choice.
You would rather have multiple choice? Oh, well then we'll do multiple choice. I personally think multiple choice is harder though. You don't think it's harder?
It's easy to pick out one.
Alright, if you want multiple choice, you're going to get it. Alright, that works then. So you'll come in, you'll take it, and you'll have multiple choice. So I'll review everything you need for it. I'm going to write them this weekend, or maybe over the next couple weeks, I should say, because we have a little bit of time left. If you don't like this particular day here, you want to take it on a different day, you can take it on any one of the days that's in this, and this is available in the schedule, and the schedule is available right here from the main page of bhacker.com. Click on the link, it'll take you to the final exam schedule. All I need is to know ahead of time which day and which time. If you want, if you want like a hassle-free experience, then take it on this, because we only have 70 students. It's not going to be that chaotic. And I did break you out into 2 groups, which means if you don't like your group, you don't like your time slot, you can move into the other one. This one should not be a problem because that's the time the class normally starts. This one a little earlier. If the earlier session is not good for you, just send me an email message and let me know you're going to take it the second one. Actually, for the purposes of this exam, you don't need to do that. You just show up whichever group you want. It'd be nice to show up in the assigned group. Hello. But you don't need to. You can show up in either group 1 or either in group 1 or 2. Would work for you. Because I can accommodate everybody all at the same time. It just makes it a little easier if I break it out. Any questions on the final exam?
So will it be an open book?
No, it will be a closed book, closed notes, closed internet, closed neighbor, closed everything. You won't have to bring a Scantron or anything. All you have to do is bring a pen or a pencil, and you write on the exam, and your student ID if you have one. Otherwise, if you know your student ID, write it down on a piece of paper so you have that available to you. Because what I don't want is multiple people taking the exam for one person. Or, no, one person taking the exam for multiple people. That's how it works. So they come in and they take it over and over again. Because the last times I've done this, I have noticed a few things like that. So we're being ultra careful in terms of who's taking what exam where. And if you're taking multiple courses with me and you'd like to take them all on the same date, same time, you can do that as well. Depends. Some students are taking multiple, some aren't. So, any other questions on the final exam? Nope. Did we finish lecture 6 on databases?
What will be the pattern of the questions paper?
Oh, it will be multiple choice.
Okay. How many questions?
I don't know yet. I haven't written it yet. The exam for this particular course, is it worth 25 or 30%? 25%. It might be 25 questions. 1 point a question. I'm thinking that's probably a good standard. All right, so last week we covered databases. Talked about database technology. I'm told that we covered the whole thing, which we very well could have. I don't remember. I'm sorry? Oh, well, hold on one second. Let me put that mic on then. Was this running?
No.
Okay, you can start it, I guess. Technical difficulties in the new building I see already. We are working it out, though.
Yeah, I already started.
Okay, very good, very good. All right, so I believe then if we've already covered the database stuff, then we're going to move on to decision support and artificial intelligence, which is lecture number 7. And lecture number 7 is actually kind of interesting, and I like this topic in particular because it's a multidisciplinary kind of area of information technology, information systems, computer science, software engineering, artificial intelligence, psychology. All of these things are kind of wrapped up into one. And we call it business intelligence or decision support in terms of that. So brain power of the business, per se. So what I'm going to do is compare and contrast decision support systems with geographic information systems, which is more of a cutting edge technology these days, and define what's meant by an expert system, describe different types of problems that they are applicable for. You can't use an expert system for everything. In fact, a lot of this business knowledge information only applies towards certain decision making that can be done. You can't design your entire business along these lines. And designing and looking at, looking at neural networks and fuzzy logic as a concept in AI tools, looking at genetic algorithms, and describe 4 types of agent-based technologies is what I'm going to end up concluding with. And I'll probably get through this whole lecture today. It's actually kind of, it's only about 37 slides or so. It's kind of a short lecture, but it's kind of short and sweet at the same time. Everybody has heard of Google Maps, probably. You all heard of geographic GPS systems and geographic information. Starting to see a lot more of it being used in information technology, information applications, business applications. If you think about it, most of what we're trying to do is track customers, find customers, service them better, promote our product, sell our product. All of these different things combine in with the need for geographic information. So we can have visualization and visual information that we can use as a technology to wrap it in for, as an example, visualizing information in a map to form a basis for decision making. So the geographical information system is GIS. Why they want to make it a separate information systems topic, I don't know, because GIS and IS are pretty much the same thing if you think about it. It's just information. One's in the form of geography. The other one's in other types of data. We don't say mathematical information systems, or it's just different types of knowledge. So what we're looking at is being able to see a map spatially, graphically, seeing data. Perhaps a good example of that would be what we're seeing in the Verizon commercials. The map with all the red dots, and the guy sits at the restaurant, and the dots fall on him. And the dots are telling us graphically on the map, on the globe, where all these customers are. Or it's actually, that's what I thought the graph meant, but I guess it doesn't. It says where the service coverage areas are, or something. I don't know. What exactly those little red pins stand for, I have no idea, actually. But it's information, apparently, about maybe where all the customers are. Think about it. If you see more red pins up there, you see the network's pretty congested, it looks like. So I don't know. So I know that's not what that means. Researchers, scientists, all sorts of people use GIS to map out the location. Debris of shuttle, let's say, debris from shuttle Columbia was used. That particular application was used to map out pieces from that. In terms of commercial applications, every one of the car navigation systems has some sort of ability to use a GPS mapping to get from point A to point B. We can find restaurants, hotels, a bunch of different things that way. We see on applets on phones, find a free parking space applications, book a reservation, do all sorts of different things depending upon where you are in the world, in the map, I should say. And how does that give business intelligence? We can use it to further along, going to the theme of strategic information technology. We can use GIS as a technology to come up with new applications, new products, and new services to help automate our business. As an example of that would be, if we had a tag on every piece of inventory, that was in the store and we had a Costco. Imagine how big Costco is. We could look at a map and see how organized everything is and saying, you know, someone needs to go out to aisle 10. It's in dismay. You know, it's all over the place or something. And we can, you know, perhaps better shift our people who are out there cleaning things up, messing, you know, organizing. Or we could actually kind of see the movement of them and track through time. Because if you think about the concept, if you're tracking everything geographically, it doesn't necessarily mean all over the world. It could be in a particular building in terms of Costco. Then we can better organize the work effort. We can watch it, monitor it, record it, fast forward through it, see the sequence of how products move out, and we can actually redesign the layout of the store. Perhaps if we see, if we're tracking customers and things, you know, going over here, then going over here, going here, and then maybe, you know, just put everything together. All these customers are buying or something. You know, use it as more intelligent ways of organizing the merchandise, displaying the merchandise, going through the inventory turnover, control what products are selling better. You know, who's picking something up, putting something back down. In terms of business intelligence, there's a lot of application that's none of this stuff exists yet. This is all like fantasy operations. We could implement anything, any one of those ideas. We could also take it to another extreme and build applications that use somehow spatial or geographic information to provide a service. It could be a matter of just, instead of using automatic tracking, let's say on package handling, just put a sticker on the item and track the item. So you know it's in a plane. Oh, it landed, or you know it's here. You know, it's going to track people or something. In fact, we have that sort of with the iPhone. There's the ability to look at where another iPhone is actually located and follow it around. Parents do that to kids to monitor where they're at, stuff like that. So in this particular example in the slide set, the city of Chattanooga uses GIS to map the location of its 6,000 trees to help develop a maintenance schedule. So, track trees. The city of Richmond, Vermont, or is that Virginia? What's VA? We don't know. I don't know either. I'm terrible. I'm a terrible American. It uses GIS to optimize its 2,500 bus stop locations in its public transportation system. I can tell you that golf carts in the state of California, which at CA, they use GIS to track the golf carts. I know that in the city of Campbell, some of the Safeways use GIS to track the shopping carts because one of the things is the shopping carts leave the shopping cart area, or they leave the block, and then they end up with some homeless person down the street. So they use this tracking device to tell you, oh, one of them's leaving, go out there and get it. Or, you know, to go find the golf carts, go find the shopping carts and things. You know, actually, I'm not sure if they have it on the buses out here, but they probably should put them on the buses. I'm sure they have some sort of an electronic radio tracking, because you always know the schedule. You can go online, actually, through Google Maps and see if the buses are behind schedule, actually. It tells you up to date. So I know there's some sort of tracking going on, and that's a good application, business use of that technology. Sometimes a picture is worth 1,000 words. Looking at a picture instead of reading data about the picture. So it can be used to graphically display information, and then recalling from Lecture 1, the form of the information often defines as quality, in terms of how good, garbage in, garbage out, how good the information actually is. If it's presented in the form of a picture, it might actually give you information you may not even realize is being presented. Okay, so visualizing information in terms of making decisions from it. Some of the questions to ponder might be, you know, do you use web-based map services to get directions and find the location of buildings? Everyone at this point does at one point. In fact, you probably had to map out the routes if you're not driving to get here today. And, or actually, if you were driving to get to the new building, I mapped it out to see which one was the shortest route. In what ways could real estate agents take advantage of future GIS? Actually, that's an interesting question. There's a lot of articles, recent articles out on how to utilize that, because what does everybody, they want location, location, location. They buy a house, they want it in a nice quiet neighborhood, or they want it with a lot of neighborhood with a lot of kids or no kids, or they want some geographic kind of spec. So if you graphed out everything, then you can just pick a random location and go, and it would either meet your criteria or not meet your criteria. You can get like a quick yes/no on it by looking at, you know, trends, traffic, and stuff like that. So how could GIS software itself benefit a bank wanting to determine the optimal placement for ATMs as well? If it tracked all the customers, it's kind of like the Verizon wireless map, I guess, telling where they're coming from. Companies do this for opening and closing locations all the time. So when they ask you for your zip code, they're usually interested in figuring out where you're traveling from, because they're going to use that zip code as a means of figuring out maybe we should move our location closer to you, or maybe everyone's coming from this location, or, so they can kind of essentially learn more about that. So in terms of the decision-making process, kind of given you an overview of graphical information systems and how it might be able to be used in terms of a concept. In terms of the decision-making, which is what we're interested in doing when we're applying it to business intelligence, we're looking at the concept of intelligence, design, choice, and implementation in terms of the phases of the decision-making. So in terms of the intelligence, we're learning, we're finding and recognizing a problem, the need for the opportunity. We're considering all possible different solutions in terms of the design. We're weighing the pros and cons of each one of the choices, and then we're implementing or carrying out the solution. So the 4 phases of the decision-making works in terms of intelligent, what they call intelligent decision-making using technology. Works, and these are the phases I just read off to you a few minutes ago. Finding what to fix, finding the fixes, picking a fix, and then applying the fix. And then going back up, back to the choice phase, back to the design phase, back to the intelligence phase, going back up the ladder to provide feedback to see how well the decision process actually went, and then making any changes that might be needed to adjust for future decision making. So types of decisions that you might be faced with: structural, non-structural, reoccurring, non-reoccurring types of decisions. In terms of the structural decision, the processing certain information in a specific way, so you will be able to get at the answer in a pretty quick fashion. This is like structural decisions can be made from databases normally. So we have a database, we can run a query on the database, we talked about last week, and we can figure out, we can do some data mining, we can make a decision in a structure, and we always use the same process or pattern every time we make it. When we look at non-structural, you might have several answers that might be correct that you can pick from, or you can pick the best answer or one that you like, given all of the unstructured information that you might be exposed to. So in a database, you're going to get a number, a count, something. In a non-structured environment, you're going to get likelihood, probabilities, less statistical analysis, a lot of different techniques that go into that kind of decision making. The recurring happens repeatedly over and over again. The non-recurring, the ad hocs, when you make infrequently, that's which store are we going to close? Where are we going to move the IT building to? That would be an infrequent, hopefully, decision that's going to be made. And here's our types of decisions that you're faced with the reoccurring on the top, non-reoccurring on the bottom, in terms of the arrows, and then unstructured to structured. We see the easiest one to make is the reoccurring structured decision. That's how many items to order. Well, we had 5, now we have 0. Let's order 5. Or let's, how many, inventory control. So that's pretty easy. We can just look at the numbers. Most difficult is going to be in this particular quadrant over here, the unstructured, non-reoccurring. That's where GIS actually falls into the place, because GIS is not structured. What do we have in geographical information systems? We have trees, cars, people, the world, essentially. So that's actually leads open some interesting opportunities to investigate information from a technology point of view to make those decisions easier. So that's pretty much the goal these days in terms of applying GIS. In terms of the decision support systems, in fact this is kind of from MIS, the first Management Information Systems class. The DSS is the highly flexible interactive system designed to support the decision-making process, where you feed it a bunch of information and it comes back with choices and options and things like that. You should consider going broke, or you can consider moving. You should consider some other things in terms of the decision analysis. And so the support system, you analyze, but you must know how to solve the problem and how to use the results of the analysis. So it's not quite as straightforward. The DSS systems that are in existence today don't give us all of the answers. It's not a hard, fast way of making decisions. So we have a lines between you and the DSS system in terms of how you're using it. And this is what we get with a lot of GIS applications, because we're looking at a map. We're looking at something. We have to actually read the map. Looking, well, we could go this way, or we could go that way, or, this area has got a lot of trees in it. I'd like to go camping over here, or no, this is an open space area. Or you can kind of look at the way clusters and other parts of the data represent itself, and then you actually have to analyze it yourself and build the correlation. So what you bring is experience, intuition, judgment, knowledge. You know what you're looking for, hopefully. The advantages of the DSS system is increased productivity. Rather than going out and running all the statistics yourself to find out how many trees, you can look at it and go, oh, it's populated. There's a lot of trees there. Increased understanding, speed. It's faster to look at a map than it would be to draw it yourself. Flexibility, reduced problem complexity, reduced costs. What IT brings, the speed and information, the processing capabilities. The abilities to automate it, make it more efficient in terms of building an application to read that map and process the data somehow. Components of the decision support system might be the model management component, the data management component, and the user interface management component. So it's kind of like building any other type of information system. We have the underlying algorithm, which is the processing of the system, or the management, which is going to be able to tell us our year-to-date sales, or tell us information that we're looking for. The data is where it comes from internal, external sources. It can come from anything. In fact, that's where we can say, well, just plug in some GIS information in. Then we can find out which areas of the world do our customers purchase most of our products from, and what's the climate in those areas or something. And then the user interface, which can be anything these days. It's just some way of interfacing with the underlying system so that we can come out with some interactivity. Here's the components put together graphically. We have Bob here in the middle. Bob's saying something. So Bob says, what financing options will cost the least to buy the house when the principal and the interest are all paid? What options will result in the lowest monthly payments? He looks like he's trying to buy a house. And then now Bob might say, after he asks all these questions through the user interface, he has the choice, picks a model, goes through, there's the underlying data that's composed for him. Now that I've figured out the total cost of the loan options and also the payments for each of the loans, I can use the information to make the final decision on financing, hopefully, which is essentially what he's basically trying to do. So he's asking questions, getting answers back through the interface. And this is how we're using systems in terms of a lot of our modern day applications. And we call them, for the most part, knowledge-based systems. So, as an example, you go online. Actually, in the old days, you just pick up the telephone and call a travel agent. Say, how much is it going to cost for a ticket? What's the availability of a ticket between San Jose, California, and, I don't know, another place in the world? Okay. And then they come back, the $250. And you wonder, where'd they get that money? Where'd they get that price from? And you call back 10 minutes later, $395. Oh, wait, it jumped in price. Because at any one moment in time, the knowledge-based system over here is basically calculating out how many people are calling in. Which is kind of interesting. The more people who call in and make requests, and which is bad because they always put the reservation on hold for 24 hours, the more hold reservations, the higher the ticket prices go up. So, people call in multiple times. They got many different companies in the old days. Now they don't do that strategy anymore because people put everything on hold. The entire flight's booked. Everything's locked. And then prices are skyrocketing. And the next day it's down to $199 because all the 24 hours elapsed and all that stuff automatically rolled off the system. Now we do it on the internet. So what happens on the internet is we have search engines, programs, or should I say search engines that are built into programs, for cheapflights.com and stuff like that, that do some aggregate adjustments, and they find the oddest seats, like the one seat that's left on this flight. They tell you that this one's $199 because if they sell that seat, they're going to make a commission on it, and it's not a very sellable seat. You have to have a single solo passenger running, or maybe it's 2 aisle seats, that are back to back or something. I don't know. So it does funny calculations to figure out, and usually in those cheap flights, you're getting the worst seats on the plane anyway. You're getting the cargo loaded back, the back of the plane, or you're getting something that's not very desirable, a center seat or something. And and it won't allow you to make any adjustments. So if you assume that, then you know that you're getting the cheapest price and the cheapest seat on the plane. But that's an example of how it's used. In terms of the geographic information system, so we've looked at already, it's part of a DSS. So the DSS is designed specifically to analyze spatial information. And so the spatial information is anything on the map, anything that is being captured, which is interesting. We have a lot of data. So your car, in fact, most of the primitive GPS systems on a car only had roads, or they had bridges, or sometimes it's empty. Have you ever run into a situation where you've been, sometimes when I travel I see that and it's like, off the map. Like, the map doesn't cover this part, or this street's gone, this street's not on my map, or I have white space or something, because the data's not there. And so you're not going to store all data about everything, and it's not always going to be up to date either, unless you constantly update it. However, what you're trying to get is all of the relevant information that's going to be used by the search engine or the inference engine to make those decisions. So what are they primarily interested in is roads and streets and things. So if you asked it for a bicycle route, it may not necessarily be able to tell you that, which is why, you know, in order to do something like that, you have to put it on the internet. You have to have a huge database, like Google as an example, has everything. So, but they can afford to put it on a huge server. You can imagine how many disks it would take to put in your car. Wouldn't be available. But when they start making cars internet aware, are there any cars on the market that automatically connect to the internet? DSL connection? I don't think we have that. Because if we had that, all we had to do is put a console in the front, and then we would have everything. Because we have a connection to the internet, put a little web browser there, we got everything. We got mapping applications. We would turn it into a big iPhone in the car, or iPad in the car. People are actually starting to do that. The only problem is you can't get the constant internet connection every time you go through a tunnel or wherever you travel, so it might not necessarily be reliable. But that would solve the problem of the data and the large data set that would be needed for a lot of different applications. So businesses use GIS software to analyze information, generate business intelligence, make decisions. Here's Zillow's GIS software for Denver. It kind of goes through, I'm not actually familiar with this, but it looks like it's finding homes in terms of searching for a house. Real estate companies use this a lot, actually, to find. In fact, a lot of real estate companies, you'll see them actually printed out, maps and things printed out and posted on walls. You see, like, this area here is cheaper than this area here. And it's all usually by zip code. And, so it shows you the public school system, the routes to the freeways and stuff, because people have different criteria for what they're looking for. You plug it in, the GIS system comes back and tells you, this is the neighborhood you want. this is the zip code you're looking for. You know, okay, given what it is you're looking for. It would be nice to do that with more than just real estate, actually. Artificial intelligence. So going back to the beginning, when I said GIS is part of artificial intelligence, it is. It's working with large quantities of graphical mapping data, but applying intelligence to give you business intelligence through artificial intelligence. So it supports for decision making. You are still completely in charge, not given the whole sci-fi artificial intelligence of the past where the robot just takes over. Instead, you're using an algorithm, you're using a routine instead of having to do it manually. It's kind of like a human using a calculator instead of doing math by hand, manually. So artificial intelligence, by definition, the science of making machines imitate human thinking, behavior, replaces human decision making in some instances. Our cars have artificial intelligence built into them, actually. Well, now we have cars that will stop, cars that will park themselves. That's an example of using artificial intelligence in a product. They fall into a couple of different categories. I'm not going to give you an entire course on artificial intelligence, but you could take an entire course on this. Expert systems, neural networks, genetic algorithms, and intelligent agents. I'm going to actually talk more about the expert systems and the intelligent agents because in previous classes I've given you already the neural network information and stuff. That was more of the IS class. But the expert system is interesting because we're using a lot of them. Expert systems are driving most IT applications these days because we don't want to go and find all of the open ports on the computer. Just tell us which ones are open. So we have network diagnostics that tell us, which users are hacking in or potentially hacking in, which ports have a lot of activity, which stations, you know, have timed out a lot. What is our constant bandwidth capability in terms of what it is we're achieving and what it is we're supposed to be achieving? So experts, knowledge-based systems. So it's an artificial intelligence system applied to reasoning capabilities to reach a conclusion, and by definition, used for diagnosing problems, prescribing, prescribed problems, what to do, what went wrong in terms of faults in the system. Traffic light expert systems. This is interesting. Have you ever pulled up to a traffic light and waited and wondered, why does it always take so long? Or maybe it doesn't take so long. And then people play these tricks. Because in the old days, there used to be sensors in the pavement. So if you ever see someone backing up, going forward, backing up, they're trying to hit the sensor. So the light triggers. They're not using sensors anymore, though. Not in the ground. Some of them are actually on the towers now. So you have to be like in the middle of the lane. You can't like be crossing the. It's so weird, the games people play. But in terms of the rules, symptom or fact comes up against a rule. We have a yes or no, then we have an explanation, and we apply the rules, and then the system changes the lights for us, essentially. So is the light green? Is the light red? Is the light likely to change to red before we get through the intersection? In terms of the human, can you stop before entering the intersection? You know, are you going too fast to stop? Some people, the risk of stopping is higher than if they just went through in terms of causing an accident. Is traffic approaching from the other side? So you go through the intersection, or you go to Rule 4, or you make some changes. And what we're doing with an expert system, we're just automating all of this. We're putting all those rules in there. And then the car is stopping on its own. That'd be nice. The car would just stop when it's supposed to stop, you know, at the red light. And then nobody would ever go through a red light by accident anymore. Because we have all the technology in place. We can build the expert system to do that. Just the same way as we can build it to park a car. So, you guys are familiar with that story that was on the news about a couple weeks ago. Well, there was a kid playing with a ball. I don't know if I mentioned it in this class or it was a different one. Got ran over by somebody parking a car because he was in a blind spot. I don't know if the kid died or not, but a kid was playing with a ball in the gutter. The ball went into the gutter. The kid went down to go pick up the ball, and he got run over by a woman who was backing up parallel parking. So then they decided to put cameras and a sensor. So they improved the technology, applied it to the car, and then they were showing it on I think it was Channel 5 News or something. And one of the news broadcasters was experimenting with the new system. And they put a ball back there instead of the kid, obviously. And the system still ran over the ball. So it didn't help. Well, all the technology implemented into a computer program still would have killed the kid. It wouldn't have saved anybody's life. So, but that shows you the point that computers can only mimic humans, and if humans make errors, well, so can computers in terms of the logic. So if everything lined up correctly, but not everything always lines up correctly, so in terms of the ball and the kid. So what expert systems can and cannot do, which that story sort of leads into the point, it can't replace stuff like that, freak incidences or things that are out of place. So an expert system can reduce errors, not eliminate, but reduce errors, improve customer service, reduce costs. It can't use common sense, and it can't automate all processes, even backing up into a car. In fact, that's why I would hesitate buying one of those cars at auto parks, so they have cars that keep themselves in the middle of lanes now, that park themselves. I don't know if I would trust the technology. What common sense, if there was a kid with a ball, the car's going to run over the kid. They're not going to have that common sense to know to stop. So, all right, neural networks and fuzzy logic. I'm going to kind of breeze through this because I've already talked about this in other classes you may have taken from me. Neural networks themselves, ANN, artificial neural network. So you see it abbreviated as ANN a lot. In terms of its capability of finding and differentiating patterns. So what we're looking at here is in terms of applying a concept, not an expert system, but a neural network to find a pattern and work with the pattern. What they can do, they can learn and adjust to new circumstances on their own, which is kind of like the neural patterns of humans. So humans, as we go to school, we learn things, I think we adjust our thinking a little bit and go, wait a minute, maybe we can apply an expert system solution to that. Okay, or we come up with these answers that from knowledge that we've gained. We can take part in massive parallel processing as well, because neural networks can actually process a lot of data quickly. We can function without complete information. We can have bits and pieces of information and still make connections, which is good. So sometimes we may not have all of the information we needed. And then cope with huge volumes of information, analyze nonlinear relationships as well, in terms of examples of what they can do. Fuzzy logic, I guess you've heard of that before. I think I've talked about this in information systems course. It's taking imprecise values and making them precise. So we can apply them to business technology as well as some of the modern day stuff that we see. And if you always want to remember it, think of air temperature controllers. It's never a constant temperature anywhere in the world. So otherwise you'd have, if it was set on 70 exactly, with 69 in here would come on. 71, the air conditioning is going to come on. It's going to constantly wear the equipment out by flipping things on and off. So 70 is really 66 to 72, 73. It's a range. It's kind of like an A is really a B plus to A minus. Kidding. Actually, some teachers do that. It's called ranging distributions. So you put scores in distribution ranges, and you go, well, from this point to this point, that's an A. From this point to this point, that's B. This point, that's fuzzy logic, actually, because you're making a precise value out of it. Applications, Google search engine uses fuzzy logic. I mean, do the exact words that you have typed in actually show up? Sometimes they do, and hopefully you'll see them as the #1 search result that's returned, but not always. Washing machines, the temperature of the water, how long the spin cycle goes for. Did it actually get all the water out of the clothes when it went through the spin cycle? We don't know. It's approximation. Dryers, actually, work the same way. Anti-lock brakes work the same way. It has to sense something. Some cars are different, actually. Anti-lock brakes, depending upon the fuzzy logic system. Same thing with any other controller. If the ranges are set differently, the sensors are different, it's going to actually have some different look and feel, some functionality to it. What do I got here? Genetic algorithms, artificial intelligence systems that mimic evolution, survival of the fittest processes to generate better solutions to problems. The evolutionary principles of genetic algorithms. And I don't know why, but this is like, for some strange reason, a lot of information systems technology people and business people, they go, oh, genetic, I don't understand that. Genetic algorithms, oh, I don't know. They're actually kind of simple. It's not, the concept, from a mathematical perspective to do DNA testing and stuff, it's more like statistics than anything else. But it's not, I wouldn't call it calculus. I wouldn't call it like a huge mathematical concept, but a lot of people run when they hear the word genetic. They go, oh no, mutations. So you have selection, crossover, and the concept of mutation. So you can build a business, artificial intelligence business system that uses a genetic algorithm to produce creditworthiness scores. In fact, credit companies, one credit card company actually uses a variation of a genetic algorithm to give you a credit score. We have in this country, we have 3 different credit card reporting companies. One of them uses, and I think it's Asperian, uses an algorithm that's genetic based. What does that do? It takes a bunch of criteria, puts it all together. And through time, it figures out, well, a person with a good income, with a disposal, with a lot of capital, he owns a house, owns a car, owns all this other stuff, but doesn't pay his credit card bill. All right, well, they get a higher score than someone who doesn't own the house but is really good on the credit or doesn't have any credit at all or something. So it mutates and changes through time, and you put in these unknown factors to kind of mix the system up so it can automatically evolve in terms of the processes. As new things come out, you have to constantly introduce them to the system so that you can make the mix more appropriate. So in terms of the selection, it's or survival of the fittest, or giving preference to better outcomes. So in terms of, let's say, life insurance as an example, if we're going to pick random people off the street and we're going to come up with a selection criteria. We're going to use age, maybe. How old is the person? And, you know, does the person smoke or drink? Is the person overweight? Does the person have medical insurance? All these little factors would be considered our selection. And what we're trying to do is find the best selection. Yeah, we want to pick the, 19 to 25-year-old who doesn't smoke or drink, who has health insurance. That's going to give us the best customer to give that life insurance policy to, because the likelihood of that person dying is really slim. We're never going to have to pay out. This is what auto insurance companies do when they get those age ranges, when they get all the demographics. In fact, auto insurance companies use your neighborhood where you live, whether you own a home, whether you rent a home, how much you make, because it's like, how much do you have to risk? Have you got an education? Do you not have an education? So people who are between the ages of 18 and 25, who rent, who don't go to college, who aren't college students, who have less than, who make less than a certain amount a year, have the highest premiums. Because they don't have as much to risk. So they're going to be the ones out there reckless driving, getting into accidents and causing problems, usually. And usually male as well. It's totally stereotyped, but yeah. Okay, and we have the crossover. So we combine portions of good outcomes to create even better outcomes. So we can say, well, okay, so the guy who doesn't smoke or drink, but he is 300 pounds and he's 5 feet tall. Ooh, okay, let's cross that over with, okay, somebody who smokes and drinks, but is not 300 pounds. Maybe they're normal weight or something. And then we can get mixtures. And I go, well, okay, this combination's good, that combination's good, that combination's good. And we cross the criteria. So we don't always pick the best all the way around the board. It's a package deal. And then we provide mutation, randomly trying different combinations and evaluating the success of each one. So what we can do is say, okay, well, let's open the group up a little bit more. The guy who is 300 pounds, who doesn't smoke or doesn't drink, let's make his premium the same price and see what happens. And then take the feedback and put it in and go, well, yeah, but this guy, he's joined a gym. Oh, okay, well, that might change the factor. That might mutate it. So joining a gym is going to mutate the result. So we put in there, we give you a gym membership along with your health insurance policy. Or put you on Jenny Craig or something so that we can reduce your weight so you can live longer so we don't have to pay the premium, which is the goal of the policy. Or the car company. Actually, that's what insurance companies do to the 18 to 25-year-olds in this country. They go, well, did you take driver's training? Oh, good, you took driver's training. Okay, good. So your premium's lower because we went to a class and you learned how to drive. So usually kids who make good grades, who take driver's training, who are college-bound or in college, have lower rates than the same kids that are same age, same demographic that don't meet any of that other criteria. And because the mutation of those other factors are going to help the end result, which is exactly how genetic algorithms work. So you don't have to have a science background to understand how that could be applied towards a business setting. What they can do, they can take thousands or even millions of possible solutions and combinations and recombine them until it finds an optimal solution. So we can work, I've been talking about a really small subset of data. You could take the world, all the statistics, put it all together in different combinations and see potential problems. And this is how they find what causes, they don't know what causes cancer, but what causes diseases, what causes cancer, what causes they go, well, women who are over the age of something or other, who smoke, who have taken this particular drug, have a 95% chance of getting this or getting that. And they can come up with all this data by doing genetic algorithms with all of this information in combinations, but it hasn't been perfected. It's not what I call a perfect science at this point. Otherwise, we would have a cure for everything. Because if you knew that combination caused something, you wouldn't do it. It's like even today, people who drink and smoke and are overweight, it doesn't necessarily make them live any less longer than somebody else who gets hit by a car in a freak accident. But, too many factors, I guess, is what the issue is. And in genetics, there's a lot of different information, a lot of different factors, which makes it a complicated area, and I'm already moving ahead to what they can't do. So I'm still on what they can do. The last point, work in environments where no model of how to find this right solution actually exists. So they're a nice replacement when no other model works. Then they make a nice replacement. And oh, I don't have that slide. What they can't do? Well, they can't do is I just explained it. Actually, they're not 100% foolproof. Intelligent agents. We've seen this in business intelligent applications a lot. We had Ask Jeeves. We had the paperclip in Microsoft Office. We have Google and Yahoo search engines. Those are intelligent agents. You give it information, it goes out and finds something. So, have you guys actually used the paperclip? Most users just say turn that feature off. I don't even think they're doing it to 2010 anymore. I don't know if it's on by default. I think the feature's still there, but it's hidden. But this little paperclip would come out on the screen, and it was animated. All the Microsoft Office products, it would sit there and go, hey, I'm here, ask me a question. It was very annoying, which is why people just clicked and got rid of it. And then for a while they had websites where they were putting out animated things on the site. Say, hey, click here. Like, hello, I'm here, click on me, and I'm going to help you make your decision. But what it is it's acting as a search engine, it's acting as a decision maker. You're giving it some information, it's telling you an answer, which is what an intelligent agent actually does. Or you're giving it information, it's going to go find a solution for you. Or it's going to go and retrieve. It's going to do some work for you. So the agent is in fact, if they called it an intelligent person, and that would be any human, intelligent human, any human that's really good at decision making, manager, boss, would be the equivalent. But we don't have humans on the internet. Well, we have them attaching. We have humans connecting to the internet, but we don't actually have them on the internet. There's nothing alive on the internet. We have agents. So the word agent came out as a replacement for a human being. So software that assists you or acts on your behalf as an agent in performing repetitive computer-related tasks. So types, information agents, that's what we get on the internet. Monitoring, surveillance, predictive agents, those are the network tools and things where it goes out and monitors open ports and figures out, someone's been trying to enter into this port for the last 5 minutes, block it automatically without actually having the human do anything. The little messages you might get from your bank, the little text messages say, hey, your account's getting low. Or your account's empty. You might have identity theft going on. Like those. Actually, credit card companies use the concept a lot. That's where you get those calls from the fraud detection department. And they ask you, do you have your card in your possession? And why are you just calling me randomly to ask me that? It's not a random thing. It's because the system came back and said, so-and-so has used the card in Arizona, 5 minutes later used it in Florida. 5 minutes, and like, wait a minute now. How could that person be in all these different locations? Yeah. You could be if you're shopping on the internet. But normally transactions don't occur in that type of frequency. That's that fast. So it puts up a red flag. The intelligent agent comes back and triggers, and somebody gives you a call, hopefully, to let you know that your card is being used. Data mining agents go out and find information and report back what it's found without you even asking the questions. In fact, the big difference between data mining and search engines, we're giving it information. Data mining, it's giving us information. We're not asking for it. User or personal agents can actually, it's like the special agents, people out there that are doing things for you automatically. Information agents, the most current variety, where we have information agents, intelligent agents that search for information of some sort and bring it back to you. That's the Google search engine. Buyer agent, shopper bot, shopping bots, all sorts of different types of agents on the web that help you, the customer, find products and services, things that you might want. That would be really nice, actually. Let's say you were shopping for a car and you wanted a let's say this is the year 2000. You wanted a 2010 smart car. Actually, you don't want one of those. But let's say you wanted one in a blue tinted window. You put all the specs in there, right? You put it out there. This would be a nice feature. I don't think it really exists yet. I don't know. And you want to pay $5,000 for it. And then when this happens, send me a text message to tell me that it's available and give me the URL so I can go take a look at the pictures of it and stuff like that and where it's located. And then all of a sudden we come back and you give it all the information to the information agent. And then, lo and behold, 3 days later, you get a text message. Your car is available. It is, really. Because that would save people a lot of work. Because when people go shopping for a car, they all go online and you go here, you go here, you go here. Wouldn't it be nice to just have something go out there, span the entire information that's available? The second that thing becomes available, you know about it, so you can go ahead and go out and purchase it. It's kind of like how you watch items on eBay, but it's not, it's manual, and you actually have to, the human actually has to be involved in it. The concept of the intelligent agent is more along the lines of the non-human, the computer, actually doing the work for the human, which makes it a lot more service-oriented. Monitoring and surveilling agents as a concept. To monitor and surveil means to predict in terms of predictive agents, provide feedback, correct the agent. So they're constantly observe and report on some entity of interest, network, manufacturing equipment, as an example, which is kind of like what happens in the best of all worlds with technology. You have a perfect manufacturing line, and everything's running great, and then all of a sudden everything stops. Because what happened? And then you go out there, and it's a huge warehouse. You're walking up and down each one of the aisles. This machine's okay, but you know how long it's going to take you to figure out where the problem is? So you send out a monitoring agent that automatically tells you, machine number 5 on aisle 10 is low on oil and it's overheating. Oh! So now you go in and you get your brand new vehicle serviced. They hook it up, actually depending upon what age your car is. Now you go in for, even actually my smart car as an example. Okay, so the smart car is really smart. You know why? They plug the thing up to a computer. And the computer monitors and surveils everything. And it tells you within the last month, or the last time you had it serviced, what happened. It gives like the entire history. And like on this particular day, this particular time, it had a gear malfunction. And then, like, the person driving the car never even notice it probably, but yeah, that kind of tweak. So it can kind of give a better, higher level, smarter diagnostic because there's an agent out there watching everything as the user's using the car. And then they clear the memory out, and the next time you come in, they do other things. But they can predict ahead of time, oh, your transmission's going to die on you eventually. Oh, because it's having all these problems. We have a software upgrade for that. And actually, everything is controlled by software. So. All right, data mining agents. Operate on the data in the warehouse, discovering information. And that gives essentially opens the door to new types of applications instead of doing a database search or mining it. User agents, those are the personal agents, as I mentioned before, intelligent agents that take action on your behalf. And examples would be prioritizing email. Not everyone does this actually, but you can color code in some programs. Say, hey, if it comes in from my boss, make it red. If it's my sister, make it green. You know, prioritize it by color. Maybe as a gaming partner, you know, you're going online playing Jack. My dad actually does this, plays blackjack and poker online for like, you know, pennies and nickels and stuff. But he's playing against a computer. He's not playing against a human. So, but there's a sense of gambling with an agent. Assembling a customize news reports, news feeds. We do see that in applications all the time. Filling out forms for you. That's lovely, but also scary at the same time. When you go to a website, it's already filled in for you. You're wondering, where's all that information coming from? My computer, my cache files. Uh-oh, I've got cookies filled on my computer. And then you know, oh, I better clear out my web browser. Clear out all of that personal information. It already knows my social security number and where I live. Ooh, that's not good. I can also discuss topics with you. This is the help systems. To go back and point, did it solve your problem? No. Do you still want to continue trying? No. Okay, you call this number, you can get support 24 hours a day, 7 days a week. Okay. Multi-agent systems and agent-based modeling. So we looked at a bunch of different little systems. If we put them all together, we can create a combination that might actually be beneficial. We have biomimicry, learning from the ecosystem, adapting characteristics to human organizational situations. They're used to learn how people-based systems behave, study of behavioral use in terms of user interfaces, in terms of application development, predict how they will behave under certain circumstances. Now, if people really did this, we wouldn't have any applications that suffered from too much bandwidth or from overload. We wouldn't have to do any load balancing, essentially. Improve human systems to make them more efficient and more effective, perhaps. In terms of the agent-based model, the agent-based modeling, and then the multi-agent system. So the agent-based modeling is modeling the solution after the agent, so that way of simulating the human organizing multiple agents, putting them together to follow a set of simple rules, can adapt hopefully to changing environments. This would be if you could figure out, an agent-based model would be to figure out how to put a human, you know those crash test dummies they use in the commercials? Alright, car test, they put the dummy in there and it rams into the wall and they say, oh, the dummy suffered a concussion. Or the dummy broke its back or leg. They don't really know that. But there's computer sensors in the agent. That would be an example of an agent-based modeling where you've got a human modeled in terms of, because we don't want to destroy a real human, and we know that they suffered severe brain damage and they're in a coma for the rest of their life because they hit their head on something. So we put a piece of rubber up there or something like that, to prevent that in the future. Or we know what happened with the car. We put sensors on the cars and stuff like that. To build an agent to drive a car may also be a possibility. So multi-agent system, group agents together, gives them the ability to work independently and then act with each other. So base them together. So let's look at some business applications that use agents as a concept. So we can apply this to information technology. And Southwest, cargo routing. In fact, most routing companies, Federal Express, UPS, they're all using agent-based systems to have something determined ahead of time, given traffic, given flight conditions, weather conditions, amount of flights versus train, buses, all the different routes of modes of transportation. Pick a good route. P&G supply network optimization in terms of a supply chain management. Who can deliver this at the lower cost at the right time. Air Liquide America, reduce production and distribution costs. Ford, balancing production costs, consumer demands. All sorts of different types of applications that can work with. We have a new type of intelligence, not mentioned yet. Swarm intelligence as a concept, or collective. In fact, they used to call this ant theory. Now they call it swarm. So the collective behavior of groups, which is why they call it ants. You know how you see ants, you never really see just one ant. You see a swarm of ants. You see a whole group of ants. They all travel in packs. Birds do the same thing. They all fly together. Occasionally you'll see one or two birds, but you usually see a flock of birds going through. So you can do this with humans. You can do this with data. Take data and look at them in groups. And that's what you get with swarm intelligence. You get the concept of patterns of groupings and how they're behaving and where they're moving to. So you can do predictions. This group of seagulls is going to make it to the south coast or something. Or they're flying south for the winter or something. Or these ants are going this trail instead of that trail. So you look at groups of simple agents capable of deriving solutions to problems as they rise. And then eventually leading to maybe some global patterns that might exist out of that. So it's actually a form of data mining. And it's not that old. It's actually kind of new. It's one of the newer things. Characteristics, what makes it good? It's flexible, adaptable to change. You can apply it to almost any concept, more than just ants and birds and things. People you can actually apply it to data, buying patterns and things. It's robust. The tasks are completed even if some of the individuals are removed. So all you need is a few random samples out of the entire group. You don't need to count everybody's activities. Decentralized. Each individual has a simple job to do. So each ant is just doing something, just whatever it has to be doing, and then you're looking at the pattern of all of the ants together. That's what you're looking at. So that was everything you ever wanted to know about decision support and artificial intelligence. Probably not everything, but it's a sampling. It's in terms of how it applies to information technology and the strategic advantage. For those of you who came in late, I posted, I'm looking at you, I guess. I posted the final exam schedule. If you have any questions, you're good? Okay. I also mentioned to the class, it's posted out here on bhacker.com, I also mentioned to the class that we have some flexibility. But for this particular class, you might be better off going with the schedule because we only have 70 students in this class. And our date is on the 27th. Something to note that's not in the schedule, I probably should have written it, is we don't have class on the 20th. So we have 2 more class sessions after today for 2 weeks left. The week before, which would be the week of the 11th, 12th, 13th, I guess it would be the 13th in this class, I'm going to go over the final exam. The final exam will be multiple choice, given popular feedback. And yeah, make sure to put your name on the roster as it's going around. And it'll be multiple choice. It'll take between an hour and a half, probably 25 questions. You may finish it within an hour. Actually, it's not going to be that difficult. It is worth 25% of the grade, of course, and you have to be here in person to take it. So if you know people who aren't here today or in the class, tell them they have to show up to take it. You can't do it online or remotely. Are there any other questions? Nope, then we're done for today. You're free to go. Swarm like ants, or what do you call it?